Hi everyone, we are on live. Welcome to our third webinar with our third thought leader GaneshRam. Thank you for coming to this webinar today, and this webinar will be about like overview on AI and ML in CAE domain. So I think there are so many excited people who are waiting for us to start. But before we start, we will give a quick introduction uh, of ourselves and then a quick introduction about Global AI Hub and the 10 million AI project, and then about our speaker GaneshRam. So I am currently the community manager in Global AI Hub. So some of our core members and community leads might start to know me more, and we will get to know each other more, I think, in the soon. So they
Um,
can introduce yourself.
Hi everyone, I'm a specialist in the field, and I am kind of like new member of the Global AI Hubs team. I'm really excited and love to making webinars like that, especially. It's just making us so excited for like get to know new peoples and get to know new topics. So I think we're gonna see us so soon in this field, as I said. Thank you, Selen, for introducing.
Yeah, thank you, Suda. And we are seeing so many comments in the comment section, so it's really nice to see that so many people are excited about the topic. And so before we start, um, let us tell about a little more about the Global AI Hub. So most of you might know the Global AI Hub. We are a community that tries to give the services, the courses to the people in all of the regions. And we are currently doing this through our platform. In our platform, we have courses like Introduction to Python or like Introduction to AI or Python for machine learning and any like more courses in our platform. And there are also country hubs in which you can discuss about the courses
Yeah.
we offer. And we also have a lovely, nice community with core members, community leads, and thought leaders.
Yeah.
And in that community, people are communicating through Discord and working on projects and keeping up the good vibe, I guess.
hmm We're
And
targeting the AI community for whole world as we're global, and we're just like targeting the people to join us in this field.
yeah, and also we have a project called 10 million AI, and we are aiming to reach to 10 million people equally, both men and women, and give them an opportunity to reach the media literacy and technology and like all the other course opportunities and services. So and this is our goal, and we are making partnerships with so many companies to reach our goal. And so it's like this, I guess. Is there anything else?
I'm just thinking like they're, but yeah, and 10 million AI really trying to make everybody knowledge about that. You can have the equal standards for everybody. If you want to learn Python or any other education, it's only if you want to learn the AI community, we're just giving you the advantage of to learn the one of the most popular educations. So yeah, I think this one's the last point that we can.
Yeah, and also people can check you. You can also check our Instagram account, I guess, because we have a surprise for you in the next few days. So be
Yes,
ready.
we have time now. Yeah.
And I think we have gathered everyone here. There are so many comments who are waiting for the webinar, and so let's start our webinar. And Ganesh, can you introduce a little bit more yourself, and then maybe we can move on to the webinar.
Okay. Hi, all. Good morning, good evening, and everyone. Actually, this is GaneshRam from India. So I have overall of 18 years of experience in CAE process automation for different automotive industries, and apart from that, I have experience on AI, ML, like machine learning, artificial intelligence, and deep learning projects experience actually. So I am currently working at one of the great service company in Chennai. Okay, so I'm as a senior project manager. So, and I'm taking care of data science and Python, AML projects actually. So that's my brief introduction. Actually, I could tell. So, I think like let's start on the topic what we are going to talk about. So can I share my screen?
Please.
Okay. So before going into topic, so I just want to give you a let me place the contest clear stage what exactly the CAE that we are I'm talking about today. I'm going to talk about today. So CAE is computer aided analysis engineering, where if you take any component like of any kind of take a water bottle or computer or whatever the things, there is a design process that will be following that involves actually, and there will be so many validations studies will take place on top of that. So to do all this kind of things actually, from a design point of view, there are standard process that involve that take place and make sure this component is stable. Okay, and this will not break or something like that. So for that purpose we are using a finite element models, like it's a kind of a uh, elements, like it's a mesh generated. Okay, so on top of that we will be applying some kind of loads, and we will be see how the components are behaving. Okay, say example I could take, you have a water bottle. Okay, so where if you are dropping that bottle, okay, somewhere else, how it behaves, whether it is breaking or what's happening it. So this kind of design study and validations and all will be carried out by using different tools involved in that. So this is a kind of a quick like high level overview about the process that you are seeing. Like initially you will be having a CAD. So CAD is nothing but a geometry. Okay, so that is what, and it involves so many steps on that. Then we will be going into a meshing, like we'll be creating a small elements, finite element. So it's called as finite element. We'll be creating it, then we will be assemble those components as I talked about. Let's take a same example, a water bottle. You will be having a bottle, on top of that you will be having a cap or whatever the things. So we need to assemble. Then if I am pressing that bottle on top of that cap, we will come to know how whether it is breaking or what the things and all, right. So that's what talks about the boundary condition. Then we will be performing some kind of analysis, then we will be validating the results. So the below picture what you are seeing is a kind of a high level definitions. So as an example I have taken a automotive vehicle. Okay, so this is the CAD geometry, this is how the geometry will looks, and this is a FE. Then we'll be assembling different parts in a car. Okay, it may be a door, or it may be a roof, whatever the things are, steering columns, all those things. Then we'll be doing some kind of a load cases. We'll be applying a load on top of uh, on a particular component, and we will see how it behaves. Then we will do a post processing, like the post processing in the sense for that particular component, at what loading condition it will breaks. Okay, that kind of studies will be performing as a part of a design activities. So that's what the overall high level concept in CAE process I could tell. Okay, so with respect to this CAE process, as the topic is like overview on CAE process and how in this for this domain how we are going to apply a AML techniques and tells the user automatically without a manual user intervention or something how we are going to predict it and tell at what point it is getting failed or something. So that's what all about today's topic. So I'm having a few examples like use cases where I like to share the things. Actually, so let me go to the next topic. So this is one kind of thing actually I could tell. Positioning the bolts and nut. Okay, so what do you mean by this positioning bolts and nut in this sense? See, like from a library, okay, say library in the sense from our cloud database, you are having a cloud database. From the database, there are different bolts and nuts like this, okay, with the different diameters actually. So user like from the cloud, we will be pulling those datas and we'll be reading it. Okay, and here the prediction model what we can do is that for a particular component what kind of a bolt that we are going to use it. Okay, so that kind of informations we can recommend it through the system. We can build a recommendation model. Okay, and this helps for engineers to understand. Example, a door is there. In that door there will be different large diameter bolts or a nut will be using it. Okay, so if suppose by mistake in the designing point of view I have selected a wrong bolt and nut, okay, rather of user telling about this issue, there is a issue, our model will try to predict that area and it will communicate to the engineer. So that is what all about this concept actually. So they basically this will help engineers to solve their problems automatically without of manual intervention, or where you need to revisit one more time and get it confirmed. These things and all we can avoid. So that's the main intention of having this kind of a use case. So how this use case is like, as you are seeing here the bolt diameter. So we'll be just storing those bolt volume CAD in some kind of a cloud database. So from the cloud database we'll be pulling those datas and we'll be fetching the parameters, metadata of those informations. Then we'll be using those parameters and we'll be applying some kind of a finite element techniques on top of that, and we'll be telling it, yes, for this location M10 bolt is correct. So we'll be building basically a recommendation model for that, and we can recommend it to the engineer. So that is what this particular use case talks about actually. Okay, so we can build so many deep learning models by using this technique. Say example, you have a bolt image. Okay, the bolt, this kind of a geometry is there. By capturing the images of that, and we can tell whether this particular image is a M8 bolt or M10 bolt or something like that using OpenCV or something. In more computer vision algorithms, we can predict it and we can confirm it actually. So it involves a bigger scope and it adds value for designers actually. So that's what all about this particular use case. Another use case, this is very interesting use case I could tell, like we need to predict parameters. Okay, so assuming that here is my data input file. See, normally in a design environment, that data will be flowing continuously from different sources actually. Okay, so but the problem is that whether those data being perfectly used for the next level of design or the upcoming designs based on the suggestions or something like that, it's not properly happening it. So what we can do is that we can store all these data in a common repository, okay, using and store it and convert that into a SQL database, and using our AWS cloud we can pull the data, and for a particular vehicle, say example, we're having a small segment car, okay, and you wants to know about the parameters of those, the parameter in the sense for the length, width and height of a particular component, a door or whatever the things we want to know it when we are building a next level designs, right? So that time we'll be having this repository, okay, in a common things actually. Then we'll be performing a data pre-processing techniques where it may have so many duplicates or other stuffs actually. Then we will be using different our statistical algorithms. We will be identifying the outliers. Then we will build a model. So based upon the model training, we will try to predict whether for this particular parameter, what is the next kind of a parameter that we can use it. Say example, for a door length, width and height is there. If I am trying to increase my vehicle space or a vehicle height, okay, that time my door design will change, example, okay. So rather than of recreating this kind of models, okay, so by historical data, okay, by building a classification algorithms, we can train those data and we can predict it and tell for X parameters this could be your Y parameter. So that is what all about these things, and this information can be stored it in our database, or we can have a kind of any kind of a dashboards for our designers to view it, and they can reuse this those parameters actually. So that's it talks about, that's what all about it talks on automatic CAE design parameter prediction models actually using machine learning techniques. So it's basically a classification algorithm, I could tell. Okay, so that is one thing, and using this involves so many of sub concepts, okay, in deep learning methods, okay. It's the flow chart looks like a complex or a little bit of different ways, okay, but for AI people it looks like simple, but from a CAE perspective point, it's a challenging thing, I could tell. The reason why I'm telling it is challenging, so today I'm building a say example, a petrol vehicle or a diesel vehicle or some kind of a different vehicle I'm building it, okay, or a truck or whatever the thing. The components or the parameters what we'll be using is different, okay. So that time we want to use the AI technique, okay, and we need to collect the parameters, required parameters from the previous data. So that is what the expectation actually. Rather than of building a complete components, we want to build this kind of stuffs actually. So that's what. So automatic error classification and identification using a deep learning models. So in this image is there, okay, there will be two different images. You may be knowing it like face identification, okay. So similar to the face identification algorithm, we can build the same kind of approach in for a CAE community also, like where we will be labeling it, and we will be doing a masking technique on top of that, and we will be applying some kind of a model training algorithms like unit architecture or a similarity factor or whatever the algorithms that you want to do it, we can apply and we can train it, okay. So up to this part, a complete deep learning approach, okay. But for a CA engineers or for a design engineers, this particular area will not be sufficient, because they will not be knowing it where this issue is there in that particular location. In a full vehicle, if you take where this location is available, okay, it is difficult for them to identify it. So what we can do is that we need to have some kind of a mechanism that connects both the our deep learning results and the CAE softwares, like design softwares, I could tell. Okay, so for that we can have some kind of a algorithms or some kind of approach on creating the same kind of, where and all there is a issues, we can create some kind of a basic representations in the models, so that user will go and visually go and go and see that particular area and he can correct it. Because unless until if they correct manually, only the problem will get solved. But the question will come, then why we need to build a AI model? The reason why we need to build a AI model is that we will be having more than 1,000 parameters in for a particular vehicle or for particular any kind of a designs what you are doing it. So this design generation is a continuous cycle, continuous process, I could tell. Okay, so as a continuous process, the each level or each stage, this will keep on changing it. Okay, every time we cannot go and check the previous data what we did. Rather than if we have kind of a common repository and doing all this kind of AI techniques involves in that, that will automatically tell you where which is correct, which is wrong. Also it will try to tell you it will automatically, we can connect those informations through the in our CAE process tools actually, so that it will be easy for engineers to view. So that's the main intention of having this as a bigger scope of activity. Okay, so for doing this activity on a dataset point of view, we need to have at least of more than 10,000 images. Okay, so both test and train data, we need to have more than 10,000 images, then label those things and train those images on top of that, and create a representation on the images actually. So that's where the key challenges for core designers actually. Visually they need to, if they need to create it manually rather than of doing it automatically. Like currently there are like of places where they need to do validate manually. Okay, so our AI can go and predict all those things and have a wonderful Flask module on showing this kind of a changes. Actually it's a kind of a web-based applications, or some we can have it, and we can connect those informations into our tools, actually design tools, and they can visually go and check it out. So this is the another project. So additionally there is one very good value addition on top of this. Okay, so assume that there is a new designer is coming into a floor actually. Okay, where he needs to understand how you are doing it. Okay, or how predictions are, like how you are designing the components. In that case actually this model will help them to suggest a solution automatically, kind of recommending the solutions to them based on the these approaches. Based upon these parameters, we can build a self recommendation options. Okay, so that means self recommendation options in the sense, what I'm trying to tell, if I'm creating a design change, if I'm doing a design change using a generative neural networks things, actually GANs, we can recreate different shapes of the same thing, same pattern. Okay, and we can recommend it like if are you okay to use this option or not, so something like that. So this kind of a technologies and all, if we bring for CA community, right, it helps a lot actually. So that's where many things is going on, like many research or many things are going on pipeline actually. So it will be a very good option for CAE engineers or design engineers to have this kind of options in their design softwares actually. So this is that's it. So that's the reason I'm telling it's a bigger topic, which involves so many different sub projects, I could tell, sub enablers or something like that, I can tell. Okay. So that's
Okay.
what all okay. So another one is like see, here you could see a very good example, I could tell. So a vehicle is crashing, it is hitting into some kind of a area. Okay, so what is the thing that we will come to know? Same kind of a vehicle it's coming. Okay, it's a crash results actually. So when you hit a vehicle, okay, on a some kind of a area, on a fixed area, so it collects so many data by using this. Once it got crashed, actually we will be getting it so many data. So from this historical data, we can tell at what speed this particular vehicle will get crashed actually. Okay, rather than of doing a design iterations, our model can predict this one. That's what I'm trying to tell. Okay, so rather than of doing a design iterations, the model will predict on crash predictions basically, I could tell. So how we can do like same kind of classification models we can apply over here, and each part parameters we need to collect it, and we can use it based upon the time series LSTM models or something like that. We can go and predict it. So this is one of the very good interesting project that currently many people are focusing it actually. So that is one thing actually. So I want to share this information. The see the topic what we were just I was just sharing it, right? Everything is a kind of a many involves of many projects, I could tell, where we just talks on different scalabilities on with respect to the designer's point of view actually. So the reason is that on a general design process, okay, every engineers will performing different actions actually. So the model what we are going to build should help the aid the designers to solve their manual efforts. So that's the key note I want to communicate here actually. So for that we need to have so many AI models or techniques that can be used it for by the CAE community is actually, or a design community is actually. So that's what I like to share here actually, because the even though it looks like a classification model, the data what we'll be getting is a challenging part. Okay, the data collection part. And once we, because like for a one prediction, one parameter if you want to predict, we need to have more than a 5,000 rows and column of informations. Okay, and that is what the historical data will be having it. So with respect to that historical data, we need to come up with how these things can be helpful for a designers. Okay, and we need to train those parameters, and we need to do a feature engineering on top of that, and we need to tell what kind of parameter that can be predicted by the machine learning model for a designing point of view. So these are some of the challenges I enforce it from a designer's point of view, and I like to share it over here. So that's the main intention of I want to share this, have a talk on this different topics. The one another one more point is that so here on this thing actually, the challenge what AI models will be having, I foresee see that you are seeing a CAD model over here. Okay, so in this CAD model you'll be having a different diameters and the length or something like that. Okay, so but how a model will AI model will predict this thing. It's a big challenging, because it starts if you take a bolt, it starts from M4 or even less than of that, and it goes till M20 or M30, something like that. So the repository, creation of repository is itself is a bigger challenge for us actually. So we need to see how effectively we can build these repositories. Okay, and once we build this kind of a repositories, we can use those repositories through the cloud environment. Okay, we can fetch those informations, and we can uh, reuse those parameters, and we can build a machine learning model. So by using any kind of a supervised or unsupervised technique, so like kind of a classification models, we can build it over on top of that. So that is one thing actually I want to communicate it. So these are the that's the reason, like I have not created more slides, because I feel like the topics what I covered, it involves a bigger volume of informations. Okay, particularly for a AI community, because on these areas right now, the models what we are building it or what we are working on are not much matured actually. So we need to come up and we need to have this kind of a options or a functionalities in the designer, for a designers actually. So that's the key message I want to communicate over here actually. So that's
Thank
it.
you.
Like thank you, thanks for the opportunity, and thanks for the AI community for organizing this event.
Thank you.
Thank you, thank you. So any questions please?
Uh,
Yes.
So, first of all, thank you for this presentation and
Okay.
the topic you put on this table today, because it was so much technical and also so much insightful at the same time. And I think there are so many people who are working in our community, who are working in the fields
Okay.
of machine learning and deep learning. So I think this might be helpful, and a little overview about what you do. I think
Yeah.
they can reach out to you if they want to learn more, maybe how you do it and like
Sure.
some technical
Definitely.
details.
Yes. Okay.
And
Okay.
uh, maybe if anyone has a question, they can write in the comments, and we can voice them to you. And as well, and when we are waiting, I have a question. So, what you do is actually some kind of using machine learning methods in the dynamic designs, I guess. Yes,
Yes.
like not
Yes.
the
Yeah.
stable ones. Instead, like the car crashing you showed, like for
Yes.
the movements and behaviors of some stable designs.
Okay. Okay.
Yeah.
I have a question actually. Like, I'm really wondering which fields that we can use it the most, especially.
Sorry.
Which fields we can use it the most, like the machine learning, like you show the automatic side, but what was the
Mm.
other side that we can use it?
Okay. They are talking about on in AML, for AML related things you are asking, right? Actually.
Yeah, yeah.
Yeah.
Mm-hmm.
So, which field in the sense, like, see, we can use it like on healthcare domain, okay, and finance domain, okay,
Mm-hmm.
and agricultural related, all those things we can use. Even in fact, you use recently I have seen some like for a particular area, what could be the cost prediction, all those things and all we can use it. But the challenge for our designers community is that it's keep changing. Okay, it's keep design is keep changing on a day by day. Okay, if you build a model, the model should be a robust way to handle this
Mm-hmm.
frequent changes that happens actually. Okay, so
Mm-hmm.
that's the challenge we have. So probably to initially we need to take up a small kind of a areas where we can
Mm-hmm.
straight away target those areas and solve help the models to predict it. So that way I feel like it will be a very good start, kickstart for us actually. So that is one thing. Yeah. Okay.
Okay.
Yeah. So that is the main thing I want to tell actually. So that's what. Yeah. So right now it's focusing on the more on autonomous vehicles, okay,
Mm-hmm.
all those stuffs. So for building those kind of autonomous vehicles, the design is important, right? So the
Mm-hmm. Yeah.
designers, so the what I talked about is on with respect to that only actually. So as a designer, okay, so they need to use this kind of technologies, okay, in with respect to the different cases actually, then only it's add value to their things actually. So that's what. So my request is like on with respect, by implementing this kind of a technologies for a designers group,
Mm-hmm.
they will be very, it will be very helpful for them actually to solve their day-to-day design problems actually, okay, rather than of having a normal model predictions, okay. So we need to see where we can build this kind of a models and how to use this kind of a technologies for the regular activities.
Yeah.
So that's
Yeah.
where the productivity will get improved actually.
Mm-hmm.
Yeah.
That was really understandable. Thank you.
Yeah.
And also maybe for the ones who wants to deep dive into that topic more, is it possible to share some resources that can be helpful?
Yeah, sure. I can share it. No issues actually. Yeah, I can share it. That's not a problem at all. Yeah, I can share
And
it.
what are the basic qualifications that someone must have before going into machine learning in CAE domain?
Okay. So the basic qualifications, they should be good in of so basically they should did their MS in mechanical or mechanical engineering, okay, graduation or something. Then on top of that, if they it's enough they are good in design experience, they should have a design experience basically. So that's the basic qualification. And see, it's not about the Python programming or something like that. So even without Python programming knowledge also, we can learn it and we can bring the things actually. So those things are all nowadays, it's open source actually, and it's very simple, okay. But with respect to the design knowledge, they need to have as a prerequisite. So then only they can understand where to implement this kind of a technologies in their activities. So that's what. So the basic qualification is design experience actually. Yeah.
Okay.
Okay. Yeah.
Experience both in the maybe AI field and also in the design field. Yes,
Exactly. Yes.
in
Yes.
both fields, so that they can combine
Yes.
to work
Exactly.
together.
Exactly. Yeah. Yeah.
Perfect.
Even in production areas, the manufacturing areas, right? I recently gave one talk, okay, where once a component is getting manufactured, okay, before going doing a quality validations, okay, using a deep learning model, okay, so it will try to tell where and all there are issues, whether the dimensions are correct or not. Okay, I built a CNN model for that, and I was able to get a very good accuracy actually. Okay, so this kind of things will helpful for anybody like designers actually. So that's what. So it's a very good thing actually, rather than of doing a normal AI model building techniques. If you focus it more on designer's point of view, right, it will directly reach to them in a higher level. So that's what.
Yeah, it seems really helpful too,
Yes.
because like the designs are so much changing and they are also used in action, so it
Yeah.
should be predicted how it should be designed when it's used in the daily life.
Yeah.
And also we have a question from one of our listeners. And Dina
Okay.
asked that any ML models already in production? Like, is there any ML?
Yes, that's what I saw that. And I already respond for that. So in the production, like as I told, right, we have developed a deep learning model, okay, on validating the production issues actually. Yeah. So yes, it is possible.
Okay, thank you.
Yeah. Thank you. So any other questions
I
actually? Yeah.
I think I don't have any more questions, I guess. Um, Thank you again for this informative webinar because it was so much deep dive into this technical issues and more details about the ML and the specific areas that it can be used, by also including your own personalized experiences.
Okay.
And I think before we close, there is another question coming from our listener and also our car member. And Hesab asks that how to handle the data issue. How do you get the large amount of data for design to make ML algorithm useful?
Okay. So the uh, how to handle a data issue in the sense like when we are, as I talked about, we'll be using basically a historical data, right? So as we are using a historical data, so before going for a model prediction or something model building point of view, we need to do anyway. We'll be performing a pre-processing techniques. We'll be implementing it, right? So that time we need to remove the unwanted parameters that's not needed for a particular design. Okay, say example, if you take a door, okay, vehicle door or whatever may be the thing, there are certain parameters may not be needed for that particular design point of view. So we need to remove those things and make your data in a simple way. Okay, so then you start training on those things, the accuracy will start improving it. So that's how we can handle it. We cannot completely pull all the data in from the repository, and if you start building your model, it will not work actually. So case to case we need to pull the data and we need to handle it. So that's how I used to do actually, and that's the reason I'm sharing it. Okay.
Thank you. So we should first fix the data and then decide what's important in the model and then use it.
Yeah. Yeah.
So we have questions coming.
Okay.
So there is another question: is how hyper study and eyesight differ from ML and AI?
Okay, so okay, I think he's from CAE background actually. So hyperstudy and eyesight is a different tools actually, and what we are talking about is the machine learning and AI. See, the hyperstudy will be doing it manually, and we will be telling there are some issues actually. Okay, and whereas you no need to do a kind of a iteration process. Okay, so for a particular load you are applying it, and you will be doing some kind of a iteration design iterations you will be performing with by applying different load cases, load sets, and you will be seeing how it works actually. So what we are trying to talk about here, rather of doing those multiple iterations and running it and doing the post processing, all those things, I'm just telling about using the machine learning models or a deep learning models. It will predict based upon the historical data. So that's what I'm trying to tell. So that's where the difference. So rather of a designer do manually, your model machine learning model will do all these activities actually from the historical data, and automatically you can use those informations and you can suggest the design changes it will happen in the next design or something like that. So that's what I feel a big difference actually. Yeah.
Thank you. I think that was the answer to Joseph Malvin Raj's question.
Okay. Okay.
So there was another question, but it was like the same one. Again, someone also asked that is there any already AI models for CAA? But you already said that there are.
Yeah.
So I think they were all of the questions, and I don't have any question more too.
Okay. Okay.
Do you have any, Suda?
I think that was really clear. So thankful for all of this event. So I'm
Okay.
just wishing.
Yeah.
Okay.
It was a really nice webinar, and it was really nice meeting with you. So thanks again for giving your time and efforts to that webinar. And I hope that everybody who watched this gets some sparkles and ideas and inspiration from you. And if anyone wants to maybe some deep diving into AI and ML in CAA, they can reach out to you if you're okay with that too.
Okay.
So thank you again.
Thank you. Thank you, Celine, and thank you, Sud. Thank you all. Thanks for your
Here.
time. Bye bye. Good night.
Thank you.
Bye. Bye.
Bye.